Learning is creation, not consumption. Knowledge is not something a learner absorbs, but something a learner creates. A very good afternoon to respected Principal Ma'am, Ms. Pamela Ghosh, teachers, parents, and dear students. Today, we are connecting live on the virtual platform with our most valued guest speaker, Ms. Nobonita Roy, all the way from Ireland. A very good morning, ma'am, from Edify School, Bangalore, India. Before
Good
we
morning.
begin, good morning. Before we begin, I request everyone to adhere by a few housekeeping rules for the smooth functioning of the event. Please make sure your mic is on mute during the session to facilitate a noise-free environment. Please make use of chat box for quick communications. The chat box is on the top right corner of your Google Meet screen. Please do not click on Present Now button. This icon is located on the bottom right corner of the screen. Please turn off the camera video to avoid any network issues. When you have to speak, please unmute and one person will speak at a time. While speaking, turn on your camera. Dealing with a new normal. We humans are resilient. We can learn to thrive in our new normal if we have the mindset and the resources we need to adapt. Gentle reminder for a safe environment. Remember to wash your hands and use sanitizer frequently. Cover your mouth with a tissue or your elbow when you cough or sneeze. Also discard the tissue safely after use. Remember to maintain at least 6 feet away from coming into contact with people in public. Avoid going out unless you have an important reason. Do wear a mask while stepping out as it has the least risk of coming in contact with the virus. Stay home and stay safe. Wishes from Edify School, Bangalore, India. Over to Ms. Sonali. Thank you.
Good morning. Distinguished and respected Principal Ma'am, beloved parents, students, and teachers. It gives me great joy to invite you all on this platform today. I feel privileged to extend my warm welcome to all of you present here for the session on artificial intelligence invested by our Honorable Principal Ma'am exclusively for students in order to ensure that they are encouraged and supported through the digital learning systems. Many of today's generation are no longer motivated by expensive domains alone. Consequently, educators must harness the higher level of needs in order to work constructively with today's technological advancements and developments in the field. There must be more maximizing of human potential to understand the complexities of the applied sciences and its dynamics. Today, I'm honored to welcome Ms. Nabonita Roy, data scientist at Fiserv Ireland, who will introduce us to the artificial intelligence and its relevance. A warm welcome to you, ma'am. Thank you for joining us today. I'm delighted to also thank the presence of Ms. Pamela Ghosh, the principal of Edify School. Ma'am, thank you for the amount of patience, expertise, and perseverance that goes into planning and creating platforms such as these for students to explore. Let's now begin the session with enthusiasm and inquisitively open minds. Today, we are happy to have Ms. Nabonita Roy with us. Ms. Nabonita is currently a data scientist at Fiserv in Ireland and is graduated from the Trinity College, Dublin. She has volunteered to teach in Carmel School. She was a patrol leader for Bharat Scouts and Guides and has also worked as a community volunteer in basketball at Ireland. She has earned a series of licenses and certificates, and I would like to list a few of them. Fundamentals of visualization with Tableau, launching into machine learning, how Google does machine learning, data-driven astronomy, Docker's Essentials, Hadoop platform and application framework, deep learning A to Z, hands-on artificial neural networks, to name a few. We are very fortunate to have you interact with our edifiers, ma'am. Without any further ado, I would like to hand over the session to you. Thank you.
Thank you so much for that introduction, and I'm really glad to be here. I'll, without any further ado, I'll just start presenting my screen now. Uh, can you see my screen?
Not yet, ma'am.
All right.
Yeah. Yes, ma'am, we can able to see.
All right. Great. So I am going to speak about artificial intelligence today and just introduce myself as ma'am has already spoken about. I'm a data scientist at Pfizer. Pfizer is a payments company, so I work with payments data and finance stuff coupled with machine learning and artificial intelligence. I'm also a core team member with Women in AI Ireland, and I work here for education for the women here, girls and women here in Ireland, giving them a platform or say hands-on experience in what lies in the realm of AI. And then I also work as a freelance Python instructor with Women in AI and a consultancy. They're like a startup in Germany, so I just volunteer with them. So with that, I'd like to just talk about what artificial intelligence is in crux. So humans are, naturally instinctive with a mind that can think, we have an innate cognitive skill. And humans, we are like very naturally intelligent. It's debatable, but we are naturally intelligent. And but what is artificial intelligence then? So when machines, which naturally is not intelligent, act like, or it has the capability to think and also act like it is intelligent, then it's called artificial intelligence. That's basically what the definition is. But there's so much more to this little introduction, and we will figure that out next. So I'll start with a little bit of a history of how AI came into play. So if you've heard about the movie called Imitation Game is a famous movie where they have shown the life of Alan Turing, who is an important personality in the domain of AI. You can see his picture on the left bottom corner. He is widely known as the father of modern computer science and artificial intelligence. And he's also been an English mathematician, computer scientist. He's been a cryptanalyst, philosopher, and also a biologist. And he was the first person who proposed the question, can machines think? And that's from where artificial intelligence took off. The concept of artificial intelligence took up. And so he also said that this should begin with definitions of the meaning of the terms machine and think. And today, even today, we sometimes do not, because these two things are so abstract when we talk about artificial intelligence and machines thinking. What do we actually mean? Do we mean that a machine could write a poem like a human being? Can a machine write a song or have same sense of humor, would be able to laugh at my jokes? Would a machine be able to feel and fall in love, or can a machine make mistakes? And because if you code logic in a computer or in a machine, that machine is bound to perform according to that logic. So a machine should not fail, but humans fail. And that's how they learn, and that's how they gain experience and improve on themselves. So can a machine make mistakes? So these are a few abstract questions. And in this particular paper, so in every slide, I have some resources at the bottom. So when I share my slides, you could look up these articles. These are a bit probably would say advanced level of resources, but these are the actual original resources that was communicated during those times. So that was, if you've noticed the year, it's 1950, and in 1950 we were talking about machines that could think. And in order to streamline this abstract notion of what artificial intelligence could be, how could a machine think, uh, Alan Turing formulated this setting of an interrogator and two participants. So on the right bottom of my screen. Uh, so there will be an interrogator, and there would be a person A and a person B, and the interrogator is supposed to understand if A is male or female. Okay, and the job the of A is to not let the interrogator understand whether he or she is male or female. So he is not the good person, and B is a person who wants to help the interrogator. So when the interrogator asks questions like, "What is the length of your hair?" or "What is the color of your eye?" Uh, A is supposed to deceive the interrogator, and B is supposed to help the interrogator. Now he says that, what if I replace that A being A to a machine? Would that interrogator would still be deceived as nicely and as properly as A as a human was doing? So what if A, or that particular human, is being replaced by a machine? Would that be seamless transition that the interrogator would not understand if that he or she is interacting with a machine? So that's the overall, still, like, in even today when we talk about artificial intelligence and an overall general statement, we still look up to this notion that when machines think and they can act according to their rational thinking, can a human be replaced by a machine so seamlessly that it can carry out every other task like we do? All right, and so coming to the next one, this is a research proposal which coined the term in artificial intelligence. It was in 1955. It was the Dartmouth Summer Research Project that was proposed on the basis of the Alan Turing's paper. And here, very importantly and very nicely, they talk about randomness and creativity. These two words are very, very important, because when humans think and they solve a problem, creativity is one of the key elements. Now, how would you mimic creativity in machines? So creativity is anyway far from logic, and these guys at the Dartmouth Summer Research Project, they said that we use creativity to solve problems, and unimaginative, competent thinking induced with randomness is what we want to achieve at a later end. So unimaginative is something machines are. They're not imaginative, they're not creative, but they have competent thinking. Now they have to be induced with a bit of randomness in order to create some creativity. And creativity is far from logic. It is a hunch. Okay, and that hunch, you put in that randomness, you put it in a predefined, ordered process, and you never know what comes out of a piece of art, through poetry, through writing a song. And leading those things into an algorithm is even, say, a really tougher job. And probably that randomness is something that we are trying to introduce into a machine. So this is how in this paper, if you see the resource, if you read through it, it's a really detailed analysis of 1955's view of what artificial intelligence could be. And that brings me to The modern definition, there are so many definitions about artificial intelligence, but this is one of my favorite definitions that I'm going to present today. So artificial intelligence is a constellation of many different technologies working together to enable machines to sense, comprehend, act, and learn with human-like levels of intelligence. Maybe that's why it seems as though everyone's definition of artificial intelligence is different, because there are so many different aspects of it. And so the conclusion is that AI isn't just one thing. So it's very difficult to put everything in one particular framework and say this is what is an artificial intelligence. And this particular definition was created by written by Accenture. And just to expand on why AI isn't just one thing. So you could just think whenever you're trying to express an opinion, uh, as a human, you think about, say, you heard something in the news, say about the pandemic, and you heard something, and so you have an opinion about it. The say, for example, employability is going down, and you have an opinion that the pandemic has affected employability in the nation, and you can comment on that because you have certain levels of knowledge of what's going on around you. And to have that knowledge, you have to have relevant knowledge. So like you're commenting on pandemic, you shouldn't be commenting on COVID. Shouldn't be based on previous pandemics, for example, or something completely different, say I don't know, geography or history. So your knowledge should be relevant in order to be able to comment on what is the pandemic's effects on employability. And when you gather knowledge, you might have read about it somewhere, so you extracted that knowledge, and you retained that in your brain. And so that whole process makes you think, because you have relevant knowledge, you have the power to think about it. So artificial intelligence and mimicking that whole behavior of having that particular knowledge and processing that knowledge at the right time with the right resources is a difficult job, because we are using our brain, we're using our eyes, we're using our nose, we're using our mouth to convey it. We are using our ears to hear about it, and also our gestures. When I'm talking, when I'm presenting, I'm using my hands as my gestures. I am moving my face. So everything is under the hood of artificial intelligence. If you want to mimic a robot would be able to give out the same gestures that I'm giving out right now with every intonation that I make. And so it's been quite a while with artificial intelligence kicking off since the early mid 2000s, and since then a lot of advancements have happened. Now the question is, why now? You see, I have already introduced that artificial intelligence, the concept of machines can think. Can machines think? The question was first asked in 1950s, and then the artificial intelligence, the word was coined in 1955. And you see, there's always since 1943, 1945 or 1946, there was a binary ANN model. So it is artificial neural network model. And let's not look at the different keywords here. The main thing here is from 1943 to mid of 1990s, there've been good amount of research, and there've been good amount of neural networks as well. Classification algorithms, regression algorithms. There's so many different kinds of algorithms and different kinds of coding languages that were also developed during that period of time. But what went wrong, or what did not give them an opportunity to grow, and what happened after the 2000s? So what happened is we gathered immense computational power. During those days, it was really difficult to compute some even simple calculations. It would take days to compute a simple thing, and they've had huge computers, that they were large computers, large sets of computers. I've happened to know a software developer here, and she is an aged lady. She should be somewhere around somewhere around her 60s, and she's been different corners of the world, developing softwares for people. And she's been saying, like, nowadays everything is like so small and compact, like, and just share my screen and talk to you guys in this little box. And for them it was like slabs of boxes and huge supercomputers that would be plugged in together, a room full of servers. Everything has changed since then, and that only depends on something called Moore's law that you would study if you take up STEM. You would study later. But what Jenny says, that if you know, all these electronic components are made up of little chips. You would find them inside, and they are the things that run these electronic devices. And computers were big then, because these chips were not really small chips. They were really big slabs of boards in which they would have to connect a lot of things, and that's how those big machines would work. And Moore's law said that these big boards would go down smaller in size. The number of transistors over there, which fuels the computational power, basically, they are going to double every 2 years. And also the cost of that computation is going to get halved. So cost down, computational power up, and also the size is going down. So that is very true, and that has happened over the years. And that is why today, in 2020, and we've been speaking about this since somewhere around the 2005, since 2006, it really took off. And that's because of this immense computational power that we can leverage today. And also, the other thing is having the right data. Now, there are different industries which do not have that kind of right data, but every industry now is looking at how to leverage the data that they have, and they're collecting more and more data. And there've been a good upsurge of social media since, say, after 2005 2006. I used my first social media. It was tagged, and then Orkut and Facebook, and now it's come down to Instagram. So this whole evolution of social media and usage of online banking and e-commerce has risen up like exponentially. So what's happening is it's giving a good base to start any AI project, AI-powered industrial project. So that is why this is the right time that played out with all these artificial intelligence researches, projects, and every application actually leverages AI nowadays. And so, what is the state of AI now? Do you think we have managed to get that level of intelligence in any of the machines today? So, funnily, this is the prediction that Alan Turing made when he wrote that 1950s paper. You'd find that he said that he predicted machines with 100 MB storage will fool 30% of humans in a 5 minutes test. And we know that this is wrong. It's not true, because for all the different machines that has been modeled so far to satisfy this prediction, they were not innately human. They used deceiving strategies to deceive the interrogator as to not let them know. It wasn't really a strategy for the machines to think like a human or act like a human. It was more like a deceiving strategy for the interrogator to not let it think as it is a machine. So there's a subtle difference. There's a very thin difference over there. So you're coding to deceive the interrogator, or you're coding to make myself a better thinking machine. Yeah, thinking machine or an artificial intelligent machine. So there's the thin line of, say, ethics, but we are literally far from there. That didn't happen, and today we have Sophia. She's a famous robot. I'd rather include the link for Sophia. So there are a good few videos, and Sophia is a robot that was developed, and I think she has even Arabian Saudi Arabian passport, I guess, or United Emirates passport. And she is a special robot because she's the only robot that has a passport, and because she had been to different countries and provided advice. And in the artificial intelligent being, the government asked for to create a passport for Sophia. And she's been interviewing many celebrities, and she'd been talking to these people. You'd find it amusing, but you'd still, you would be very, very easily distinguish that when she's talking, it is a robot. Even if you don't see her, or if you would be definitely able to say that it's a robot. So that didn't work out for us. But we are still evolving as group of researchers, as group of industrial experts. Everybody is trying now. This, in the pandemic situation, I will discuss this later as well. But in the pandemic situation, this has become the need of the hour. Artificial intelligence, massive data coming in every day through social media because everybody is in the lockdown. So. So that's a little bit of introduction about what AI, the state of AI, and let's look at what narrow versus general AI is. It is an important question here. AI could be defined in, say, you would want to develop a perfectly thinking machine, right? But for that, you need loads of information. Say you have to, detect what that particular machine is seeing, what that particular machine is hearing or speaking, and processing that information. Over the years, because this is such a huge task with so many independent or codependent units, we rather would concentrate on looking at only one part of it. And there are different groups of researchers who look at each of these independent or codependent parts, because you see, our hearing, vision, processing, all the five senses, they are, you cannot separate one from the other. There's a whole lot, they're always like working at the back of your mind. So how these tasks are differentiated. So there's one little task which is, or subtasks which are closely related. So they're only looking at speech recognition and speech translation. So that's one part of it. Then they're just looking at how to process, say, whatever I've been saying so far. That's human language, right? So how would a computer understand what you're saying? We learn language, from, say, when we are born. Our parents are people who are around us. They just speak about things. They make us say, oh, look at that is a car, and oh, look at that's a flower. And that's how we learn. So we are these tasks, these individual identifications are the things that has trained us to understand what's the world like around us. And these are, recognition and vision, they are closely related. So they could be considered as one task. Now, industry-wide applications, so industries, they cannot invest on everything. So in the industry, they mostly look at only one particular, or that set of, closely related tasks. So that's what is called narrow AI. So even in, say, we talk about finances in banking and everything, we just deal with loads and loads of numerical data. So that's modeling for finance and predicting, say, if a person is good enough to be, to let the loan sanctioned, or to think, that particular transaction is fraud or not. So that's a very closed use case. And of course, what would Sophia do with that kind of information? So there's this distinction of what general AI is. General AI should be able to perform multiple tasks together, a well-rounded thinking sort of machine. They're mostly inspired from sci-fi films, over the ages, and they're mostly at experimental and research stage, because think wisely, uh, industries, they invest a lot of money. Why would they be interested in that kind of a research, which is, first of all, very difficult to yield, and very and would be very, very, very expensive? So that's the difference between narrow and general AI. And narrow AI is what most of us, we work in. We work all those things in parts. And what parts do we have? So most of the times, so artificial intelligence is mainly about human-computer interaction. It is a major component, and we need to have basics of cognitive science as well. We need to have philosophy, linguistics, psychology, neuroscience, computer science. It's completely an interdisciplinary subject. And as humans, we have the five senses. It's touch, eye, vision, ear, tasting, and hearing and smelling. So with touch, we already have, worked on, even when you're typing on your keyboard, that's like touching. And so we still have, we have advanced quite a lot with touches. You can move arms of robots can work, robots can work here, they can also walk. The touch thing is working, and has been working for years. The vision part is something that over the last 8 to 10 years, computer vision or machine vision has really expanded, and they've had successful understanding of, and successful trained models that can actually identify objects. If you provide a picture, a computer would be able to tell, oh, that's a car, and oh, that's a flower. And if there's something written, say, on a street, you're just walking and you're reading the name of that shop. So a computer would be able to say what's written, or what's the name of the shop. If you hold you'd find an app on your phone. If you just point it, it'll extract the digits from there. And also, one step ahead of it, if that is not in your language, they would be able to translate that as well. So that's character recognition in vision, and that's what humans do. So there's good amount of research and successful research in computer vision over the last few years, and they've had really good results. And the last one is hearing, or hearing in the sense you're understanding what you're talking about, what I'm talking about. So when I'm speaking, the computer is able to understand what I'm saying. So for example, you say Siri or Alexa, they all work on speech recognition technologies. So there's loads of natural language understanding, human language understanding, and human language recognition, and then processing that and extracting what I'm trying to say, Siri or Alexa, and then acting upon it. So, and natural language processing has been successful in the last 2 or 3 years, and that's mainly because they discovered newer patterns. You see, in computer vision, when you look at something, it's very evident sometimes. In order to encode it in terms of pixels, it's very digital. But when you talk about natural language, it's really, say, analog. It's sequential with time, and it's just difficult to put everything that a person is saying in a structure. Whereas whatever you see, you click a picture, it's very easy to navigate through all these pictures and create a good full picture. And so because that is such a digitized and formulated project formulated objective. Rather, it was the researchers and industrial experts. They have managed to get good results with computer vision, but last 2 3 years was really successful in natural language processing, and it's still going on because we still don't have a really good chatbot that can just speak to you like a friend or like a human being. So, natural language processing, let's talk about a few applications of where natural language processing fits. This is one of my favorite topics since I had learned about it. So, one of the very basics and very early days of experimenting with natural language is spam filtering. So, you've got Gmail and you see all the emails, they go into the spam folder because Gmail has learned from either you have marked those emails as spam, or in the model that they use to predict if an email is spam or not, uh, matches with those incoming emails. And so they put them all in a spam folder. So that's spam filtering. Then you have active calendar. So the code can detect Gmail. I don't know about others, but yeah, Gmail and Outlook, they do detect, say, a date, and understand that if it's a date and if it's a request for a meeting, then do you want to add that to your calendars? If you want to add that, you can just click on it and then save it in your calendar. If you've seen latest, if you've been emailing on Gmail, you'd see there is new sentence completion recommendations. So you just type I am and then glad to be here is in a fuzzy in gray text, and that's a recommendation. You could try that out. And then word recommendation on WhatsApp. If you're talking your normal keyboard on your phone, they always have word recommendations. They're not autocorrection if you've typed something wrong. So there's autocorrection, and then there's chatbots. That you wouldn't find really amusing, and it's really funny because we also do a lot of experiments with chatbots. Then they never they're never up to your expectations, and you always get to know that they work on rules rather than a complete machine learning or automated process. So that's about natural language processing. It's just how you process what I'm speaking, or if you've been given, say, a text, how would you process that text and extract the right kind of information from there? Like we were speaking about thinking, you need to extract or have relevant knowledge. So natural language processing also delves into the subject of relevant knowledge extraction for that machine to understand what he or she or it is thinking, talking, or would like to speak about. So computer vision. Computer vision applications, a very famous one would be your face detection or retina detection. So you hold your phone in front of yourself, and then it detects your facial features and tries and matches it with the picture that the phone has taken in its memory, and tries to open it. So even if it's your half face or not full face, it might be able to do that. Then you also have, if you're on Facebook or any social media, you'd see they can tag you on, they have tag recommendations. They can detect where your face is depending on these. You see there are different blue points, so they're like ridges and troughs on your face, and you would be able to a computer would be able to detect these edges and these higher dimensions of your face and the lower dimensions, that will be able to detect how and reconstruct the face and detect that that's a face. And then sometimes you could add emotions to it. So they would also, a computer vision algorithm would also be able to say if you're smiling, if you're sad, if you're anxious. So there are whole loads of things in computer vision, and it's really cool. And that's about computer vision. And so let's talk a little bit about how does AI typically work. Now, in the industry, most of the things. They work in a very typical way. You collect data like you see on this particular diagram. They collect data, then they analyze it, then you train it, train a model, train an algorithm with that kind of data, and then you evaluate the model and see if the model is performing well or no. And then you deploy the model. That means you make it available for public use, okay? And for when you make it available for public use, you could have like new data coming in from the users, and that particular when you have that trained model for the public use, that model would be able to predict with the new data that it sees. Okay, that's how it typically works. This is a very, very fundamental um, flow diagram here, make it very elementary. So this is how it works. Every AI powered product are mostly machine learning. So this is a typical machine learning or data science workflow. Now, AI is not restricted to it, because AI is machine learning is just a part of AI, and AI could also have agents. But these agents or multi-agent systems, for example, there's a famous if you go on to study, artificial intelligence. If you go on to study artificial intelligence, you'd be studying about these agents who are trying to outperform each other, and that's also a part of artificial intelligence. And then, do you think studying science is the only way to reach AI? Now, artificial intelligence is a combination of data, machine learning, data engineering, data science, and also software engineering. So I think I was reading this article that in future, most of the jobs would require at least some elements of AI, because if everything is driven by artificial intelligence, every sector would also have to have that kind of basic knowledge of what AI is, what data science is, what machine learning is. And that's what is going to be required for software engineers also. So for now, software engineers they still have a basic definition of what their knowledge should be. And machine learning engineers are basically software engineers who specialize with building, solutions which has machine learning components with it. Okay, but what's going to happen is, as we move forward, say 5 years hence or 10 years hence, a software engineer position would innately have machine learning capabilities. So there won't be any distinction of traditional software engineers, machine learning engineers. Machine learning knowledge of artificial intelligence would be a prerequisite in that case. And then so you need to have maths and statistical background, not background, you need to have a knowledge of it. And statisticians really make good data scientists, along coupled with good communication skills. Then you have to have some elements of data science, computer science. You need to have domain or business knowledge, and that is where a whole interdisciplinary bunch comes in. And so there are subjects like sociology, anthropology, linguistics, economics. Economics is a very good subject to get into AI and forecasting, predictive principles. That's all econometric analysis at the end of the day. They've always been doing it in finance, in economics, and marketing through statistics, but now things have become a little bit more sophisticated with the advent of machine learning. So they're moving from traditional analytical skills to machine learning now. And then you have neuroscience, which works on your cognitive skills, psychology, and also for psychology for natural language understanding or human language understanding, and then linguistics over there for understanding again, and then philosophy for the machine to think. So all these things, they are interdisciplinary. If you talk from arts or commerce backgrounds, you're not completely away from AI anymore. And so on the right-hand side is something that is very much core to AI. If you want to go into complete research or developing these agents or these solutions, you have to go through the same route of mathematics and physics, chemistry, biology, statistics, computer science. You need to have some levels of knowledge of all these physicists and biologists as well. Uh, Biology and healthcare is big in Europe, at least that's what I've seen. I don't see that quite often in India, but in Europe, in Ireland specifically, they've invested so much on healthcare, and so they always look out for biologists or biostatisticians who can, they do drug discovery for treating ailments. They analyze patients, and they say they look at the likelihood of a person who could have a particular disease or not. So these are all use cases in biology. So if you're interested in biology or biotechnology, you're not completely away from AI anymore, because I think it is everywhere now. Then looking at some more everyday life applications. So you have social media, you have Netflix and Hotstar and Amazon Prime, and then what they do, and also on my right hand side, I've got some fashion retails, even in fashion technology. So companies like Zalando, H&M, Zara, they all invest in AI. And what they essentially do is, you see on the right hand side box, I have a picture of a person. So they collect all these details of this person, what products or shows they have liked, what they have viewed, what they have stored in the wish list, and what they have in cart or what they've checked out. And then they do make some analysis on the right side of the box. They make some analysis, and they try to see if they can forecast their consumptions. So if today I'm using, say, if I'm a frequent user of Netflix, or if I buy like 5 clothes every Friday, because Friday is my day to chill after work, they would be able to predict that this customer is likely to make a purchase the next Friday, and would just like to gather more information and try to analyze when would me as a customer would be able to generate some revenue for the company. And they would also give you recommendations. So social media would have recommendation for friends, recommendation of pages. Netflix has show recommendations, and Myntra and Jabong and Amazon, they have product recommendations based on your search. Then they provide the similar kinds of ad. If you've seen, if you look at Myntra, so, and you visit a random page, you see those ads up in there. So they work on cookies, but then those are also applications of AI, because they've understood that this person is kind of interested in this particular outfit, so let's put that up right on the face. And then and yeah, just matching up. So whatever you're wearing in fashion industry, AI is huge. So if you've got a top that is white and a blue jeans would go with it, so list all the blue jeans at the bottom to go with it, so that this buyer, when he or she buys that white shirt, would also get this really cool blue jeans. So that's application of AI, one part. The second part is Ola, Uber, and all these cab hiring services. And then you have got travel and tourism, and the virtual assistants, they're also there in everyday life. If you have to travel anywhere, Ola, Uber, they're very common things nowadays. So what they do is they look at your locations as well, and would look at your past past journeys. They also have good chat systems with the driver, so it's just tap, so you don't have to waste time. Because if you have to, as a driver, if you would start typing, that doesn't make sense, because you might just run into an accident, and that's not good. So just tap on that message and just go, because you already know that kind of conversation would happen. So who enables that? Data science does, because that's predicting and forecasting and recommending. And then the other things, they just work in the same way, except for, you see, virtual assistants, they speak and they listen, so they have natural language processing techniques underneath. And then when Ola and Uber, they work on shortest distance principle, or avoid traffic. So routing and route optimizations are something which are an integral part of their machine learning use cases. And I have some resource down there that would help you to go through more details on how they do that. And a few mentions of chatbots. It's a regular. They use chatbots for mental health for people, elderly people here who do not have someone to talk to. If you're depressed, there's a whole sort of investigation how you could help a person, depressed person, and help that person diagnose when they speak to a chatbot. Then in automated driving cars, self-driving cars, where you're not the driver, the car drives itself. Then in bank and finance, and then translation, you would, if you do not understand anything in a language, you can just go to Google Translate, and if you're using, say, Instagram or Facebook, you see the little C translation button over there. They've grown pretty good at it, even though they do make me laugh sometimes. They're really grown really good from what they used to be. So that's an incremental learning process. And then you've got different weather apps who predict. That's another, everyday life thing. You have weather apps that predict what is the weather tomorrow, what is the weather in the next hour. So that's the level of granularity that they maintain, that every hour they can predict if it's going to be sunny, if it's going to rain, if it's not going to rain, if it's going to be a good bright day. And then healthcare is big. uh, they have loads of image analysis going on with and then uh, mm, drug discoveries, and recommending people and very interestingly, there's another use case called patient flow that I learned about it a couple of days back. And that's like, having all these incoming patients in order, and having them uh, route to the correct doctor or route to the correct department depending on what ailments they have, and intuitively also analyze their data. And I have listed a few Google experiments here. It's a really cool website, and if you have time after later on, you could just go. These the first two are my favorite Google experiment games, and they're really cool to see how neural networks or machine learning algorithms work. It's just a demonstration, and I hope you will like it. And then just about AI and pandemic, how it has gone so far. When the pandemic started, AI made it possible to monitor it, and so it enabled us to detect clusters and spot these clusters more quickly. And so the lockdowns were imposed, and it's been said that by the end of April, there've been so many, more than 28,000 papers, and God knows how many more related to COVID-19 research. And then even today, it's going on. And now what they're doing is they're trying to cluster area-wise, so using geographical locations in Europe at least, and they're trying to put those, like, they don't want to go for full country lockdowns. They want to restrict local smaller localities, and they would just have those red light or green light area in those cases. And then they are also, and these researchers are also aiding the pending and huge backlog of research that they have in cancer research and better diagnostic systems. And they also are aiming to do something that would detect and stop the pandemic ahead of time, any upcoming pandemics ahead of time. And we talk about future of AI. We've already had good advancements in terms of the pandemic and the commercial deepfakes. Commercial deepfakes are, if you've seen celebrities, and there's so many fake videos coming up about the celebrities right now, that's commercial deepfakes. And that we had a whole upsurge of these kind of things. I'm just conscious, ma'am, I'm running out of time. I need to say like 5 more minutes or 10 more minutes to finish this. Is that okay?
Yeah, yeah. Yes, ma'am, 1 second. Ma'am, 5 more minutes, it's okay? 5 more minutes, is it okay?
Yeah,
Yes,
yeah,
ma'am. Yeah, for 5 minutes, I think we can squeeze in, definitely. Yeah,
yeah. Thank you so much. So,
yeah, okay.
so, um, so let's talk about what's in there in 2021 and beyond. So there's Very interesting use case of auto ML there, my fourth point, where not only they're trying to automate everything that is there in our traditional softwares, but they're also trying to automate the ones which the use case is machine learning, with the different stages of machine learning rather, and automate those. And then that's really interesting because so far, there's some parts which are very complicated, but then some of the giants, say like IBM and Google, they have already invested a lot on automated machine learning. And then and it's predicted that for the next 10 years, there would be huge dependency of these individual industries on AI. Excuse me. And these dependencies they are going to lead to data privacy and data abuse issues. They've already been coming on the face now. It's been so last year and the year before, it was all about the three things that I have on special mentions on the right hand side as privacy concerns. There's huge amount of data and a huge amount of private data, and people, industries that do use these data, even if it's for research. It is my data. Why should I give it to somebody else? And then explainable AI is all about, AI is such a complicated black box that industries would like to, business leads who do not have a lot of research background, they would ask, okay, so you're making this prediction, but how valid is that prediction? Or how do you do it? Explain it to me, because I am skeptic about your AI model. You built it, but I'm skeptic about it. Explain that to me. And when they ask those questions, data scientists and machine learning engineers and researchers, they got stumped when these questions were asked for the first time. So now, industry-wise, a lot of these models have been replaced with some more explainable ways, or if they're going for neural networks, they're inventing or discovering more ways in which they could explain these things to the industrial experts. Excuse me. And fairness in AI. So that has been a hot topic for the last year, this year as well. And then that's mostly because there've been huge discrimination against people who are colored. And so there have been instances where a model predicted that men are most likely to opt and complete a PhD. And that's because over the last 10 years, there've been many number of women coming in, but the data was trained on like the last 50 years. And so there've been more men in those data. So the probability was just picked up by that AI algorithm that was applied, and that really impacted because that was a part of industrial, candidate screening. Even when Amazon was hiring, they had profiles from the last 10 years, and they had distinguished, saying that these women applications would not be successful, but these men's applications would be successful, because that kind of there's a bias, excuse me, that lies in these this data. And then in a car, there's been an instance where a machine could not understand a woman's voice, and then another one was where extra medical care in the US. There was a research that was conducted in 2019. In the US, the patients would likely need extra medical care were mostly, heavily favored, white patients over black patients. These kind of, fairness in AI problems, that's something that has been coming up now, that since we have achieved quite a bit, we're going to a stable point. And so these kind of other problems are surfacing at the moment. And these, even though these are corollary problems, they are very, very important. And extremely important because a huge body of research is going on in privacy concerns, explainable AI, and fairness in AI. And the last slide I have is career in AI. So on the left, I have typical careers in AI. You could be an AI engineer, you could be a machine learning engineer, a data engineer. Uh, Data engineer mostly works on getting the right kind of data because data lakes are huge. A data scientist processes that data. A statistician is also involved, like a data scientist. Would be expert in statistical analysis. A biostatistician would be a biologist and a statistician. Both, they would have a background in medical research. A data analyst is someone who just analyzes the data. They're not concerned about how the data is brought to them or what happens after the analysis. They just analyze it. Business intelligence is using those analyses and extracting business insights from that, and how would that help your industry, your business. And big data engineer, again, it's like a data engineer, a big data engineer. They are both concerned about leveraging the huge data and trying to build pipelines. How would that data flow? And then data architect is AI, or data architect is how would that whole AI software look like? Where would you start and where would you end? And an economist, an economist has been a very traditional form of data scientist, and they are still huge in demand. And I have seen successful economists, they've background in econometric analysis, and so they do predictive modeling really well, because that's what they're all about. And then right hand side, I have a few interesting other areas in AI. So one is education. So nowadays, education is all online, especially in the light of pandemic. So there's huge investment in education systems with AI, adaptive applications. They recommend courses and stuff on Coursera. If you've been through in law, if you want to pursue law, you could have you could pursue AI as well, because you could be a corporate lawyer and with an AI firm, and for that you need to have all the things you need to know about AI. In marketing, customer support, these two are the industries in which maximum success has been seen so far: customer support and marketing. And that's why there've been huge hue and cry about unemployability with the advent of AI. Then manufacturing, astronomy, and space technology, medical technology, forensic science. In forensic science, if you have to catch hold of a fraudster, you know you oh yeah. Yeah, so that's it's not really a small domain, so it's a big one. So I hope I've been able to give a very basic brief introduction to what AI is, and how could pursuing a career in AI look like. And yeah, it's just thank you very much for having me here, and wish you all best of luck.
Today, I take the opportunity to put all my gratitude into words. On behalf of the school management and all the students, I would like to thank our guest speaker, Ms. Nambinita Roy, for taking her precious time out and consenting to interact with us today. Ma'am, indeed, your words have inspired the students greatly. We are all now very informed about the amount of opportunities that we have in the field of artificial intelligence. We have been fortunate to be assisted by our principal, Ms. Pamela Ghosh. Thank you, ma'am, for your guidance. You have been a constant support and you have given us a lot of encouragement. I thank all the parents for their presence. You always help us in carrying out such important events. Last but not the least, I thank all the students for showing interest in today's program. I'm sure we are all motivated towards thinking about our career goals with the available opportunities. I once again thank everyone for making this program successful. Thank you.